Welcome. Let's understand retrieval and clustering of documents. So, how do we measure similarity for retrieval? Given set of documents of similarity measure, then we determine for retrieval measures how many documents are relevant to particular category. So, how do we calculate cosine similarity for retrieval? It's a measure of similarity between two vectors of n dimensions by finding the cosine of angle between them. These are often used to compare documents in text mining. Suppose we're given two vectors of attributes a and b. The cosine similarity is represented using the dot product and magnitude as similarity would be given as cos theta, which is equal to the dot product of two vectors ab divided by their magnitudes. Let's understand cosine similarity for retrieval. For text matching, the attribute vectors a and b are usually the term frequency vectors of documents. So the cosine similarity can be seen as a method of normalizing document length during comparison. The resulting similarity ranges for -1, which means exactly opposite, 1 means exactly the same, 0 indicates independence, and in between value indicate the intermediate similarity or dissimilarity. In the case of information retrieval, the cosine similarity of two documents should range between 0 and 1. Since the term frequency can never be negative, the angle between term frequency vectors can never be greater than 90 degrees. Let's understand web-based document search and link analysis. Link analysis has been used successfully for deciding which web pages to add to the collection of documents. Then how to order the documents matching the user query, like how do we rank the pages? It has also been used to categorize web pages. It's used to find pages that are related to given pages and used to find duplicated websites. Let's understand link analysis in detail. A link from page A to page B is a recommendation of page A by the author of page B. So if a page A and page B are connected by a link, the probability that they are on the same topic is higher than if they are not connected. Applications of link analysis are these are used in ranking query results in order to rank pages, used in crawling, used in finding related pages, used in computing web page reputations, used in prediction, and these have great geographic scope. These are used in categorizing web pages, in computing statistics of web pages, and in search engines. Let's understand document matching. Document matching is defined as the matching of some stated user query against a set of free text records. These records could be any type of mainly unstructured text, such as newspaper articles or real estate records or paragraphs in manual. User queries can range from multi-sentence full descriptions of an information to a few words. Let's go through the steps involved in document matching. First, a document matching system has two main tasks. The first task is to find the relevant documents to user queries. The second task is to evaluate matching results and sort them according to relevance. Here we use algorithms such as PageRank. K-means was first used by James McQueen in 1967. Now let's understand K-means clustering. Given a set of observations x1 to xn, where each observation is a d-dimensional real vector, then K-means clustering aims to partition the n observations into k sets such that k is less than n, and S is a set so as to minimize the within cluster sum of squares. Let's understand K-means algorithm. Suppose D set is the input and k is the cluster number. Then select k document vectors as the initial centroids of k clusters. Then repeat this. Select one vector d in the remaining documents. Compute similarities between d and k centroids. Then put d in the closest cluster and recompute the centroid. Go on doing this until the centroids do not change. So the output will get k cluster of documents. The advantage of this method are linear time complexity, and it works relatively well in low dimension space. Drawbacks are distance computation in high dimension space. The centroid vector may not well summarize the cluster documents. Initial k clusters affect the quality of clusters. Now let's understand hierarchical clustering. Suppose D set is the input, then calculate similarity matrix. Repeat this. Merge the most similar two clusters K and L to form a new cluster KL. Then compute similarities between KL and each of the remaining cluster and go on updating similarity matrix. Keep continuing this until there is a single cluster left. So the output will get dendrogram of clusters. Advantage of this method are we can produce better quality clusters, and it works relatively well in low dimension space. Drawbacks are the distance computation in high dimension space becomes difficult. It has quadratic time complexity. Now let's understand EM algorithm for clustering. Suppose let the analyzed object be described by two random variables and which are assumed to have this following probability distribution function. The distribution is known up to its parameters. It is assumed that we are giving a set of samples independently drawn from the distribution. The EM algorithm is an optimization procedure which computes the maximal likelihood estimate of unknown parameter when only incomplete data is presented. In other words, EM algorithm maximizes the likelihood function. So what is a good clustering? Internal criterion is a good clustering will produce high quality clusters in which the intra-class, that is intra-cluster similarity, is higher than inter-class similarity. The measured quality of clustering depends on both the document representation and similarity measured used. So in this presentation, we learned about measuring similarity for retrieval, web-based document search and link analysis, document matching, clustering by similarity, hierarchical clustering, and EM algorithm for clustering. We also learned how to evaluate the clustering. That completes our tutorial. Pick a further tutorial of your choice and browse through it. For further help, visit us at www.dataminingtools.net.